school. Yep. Yep. Wyatt, if we have time this period, I'll give it to you, but if not, I'll have to. Okay, so we combine them, but we don't actually multiply them because we're going to end up having to factor it again anyway, so that saves us some work. So at this point, what happens? Take the pairs out. There you go. See? You know how to do that, all right? Dividing, the only thing I'm going to ask you to do with dividing rationals or radicals is just when we have something like this. Okay? Very, very simple ones. So remember the move and remove, right? It's kind of like, this is my Cal math. Move and remove, all right? Okay, so we're going to move that square root of 5 up to the top, and we're going to remove the radical from the bottom, and we're done. Okay? The only time it gets more complicated is when we have one that might reduce. So something like, excuse me, 3 over the square root of 6. Okay. Now, we cannot reduce the 3 and the 6 because one is inside and one is outside. Okay. You can only reduce them when they're both outside or they're both inside. Okay. So think of it, excuse me. Think of it this way, right? If you got two people that are inside the house, they can work on reducing the cupcakes that are in there. If you've got two people that are outside the house, they can work on reducing the cupcakes that are out there. If I have one inside and one outside, they can't reduce the cupcakes because we don't even know where the cupcakes are. Okay, that analogy, it was working until that last part. And then it just kind of fell apart. It was working, wasn't it? It was like, yeah, I get it. And then all of a sudden you're like, what? But anyway, you get it, right? Okay, you have to be both inside or both outside. So we can't reduce this. So we're going to do our move and remove. Right, move the square root up. Remove the radical from the bottom. Remove the radical from the bottom. Okay. Now I can reduce because now I've got two numbers that are outside that do reduce. Okay. So 3 goes into 3 one time. So that just leaves me the square root of 6 up top. 3 goes into 6 two times. So that's my answer. Okay.
You never change the radical.
Correct, because these numbers are both outside the house. They can't do anything with the person that's inside the house.
So as long as outside the radical, you can
Mm-hmm. Or if they're both inside. So for instance, the square root of 8 over the square root of 2. They're both inside. So it's kind of like they're like this. Now I can reduce because they're both inside. 8 over 2 is 4.
And that would be it.
No, because what's the square root of 4?
2.
Okay. If they're both inside, we can reduce them. Okay. All right. Today, we're going to look at adding and subtracting radicals. So if I have 3 root 2, and I'm adding 5 root 2, how many root 2's do I have?
2, 1, 8.
We just randomly picking numbers? 2, 1, 4, 8. 8. Okay. This is the same thing that we would do if it was just an x. If I had 3x plus 5x, that equals 8x. Right? So what we're saying is that, okay, let's pretend, let's see. Well, let me make it simpler. Trying to simplify this, and it seems like I'm overcomplicating everything for you today. Let's look at 2 root 3 plus 1 root 3, okay? So let me do this for you, give you a visual. Okay. These are all root 3s, okay? So, Sam, I'm going to give you 2 root 3. How many do you have there? 2. I'm going to give him another root 3. Sam, how many root 3s do you have? 3 root 3s. That's all there is to it. Wow. That's simple, okay? Wow. Let me get my root 3s back. Okay, so this equals 3 root 3. Okay. All right. What if I have 8 root 3 minus 2 root 3? What do we get? 6 root 3. Okay, 6 root 3. Okay. All right. New example, new visual. Okay. Okay. So here we go. We're going to do 3 root 3 plus 2 root 7. Okay? Okay. Adriana, I'm giving you 1 root 3, 2 root 3, 3 root 3. How many root 3s do I have? 3. Okay. Now I'm going to give you root 7 and another root 7. How many root 7s do I have?
2.
Okay. Can you tell me what you have in front of you?
3 root 3s, 2 root 7s.
3 root 3s and 2 root 7s. Can I combine those in any way?
No.
Can you tell me that what you have in any simpler form? Can you tell me what you have in any easier way?
No.
No. So this is what I have. I can't do anything with that. That's what I have right there. It does not combine. They have to be like terms. And in order to be like terms, we have to have the same thing inside the radical.
There won't be like any question like that on our test.
That's all you do for that one?
Yeah, there would be a question like that on your test, but you better not get it wrong.
That's all you do.
So what would we put? Just the same thing?
You would just put the same thing.
Third 3 plus 2.
That would be your answer.
So if they don't have the same thing, it's just that.
I
There-
feel like there's definitely gonna be a curveball on you saying.
There is going to be a curveball. You're right. There is going to be a curveball, right? Thank you very much. There is a curveball, okay? Okay. So let's look at this. Let's look at 3 root 3 minus the square root of 12. Are they like terms?
No.
They don't appear to be,
They are.
but they actually are. Okay? They don't appear to be, but before we make a decision about whether they're like terms, we need to make sure everything is simplified first. So we're going to simplify this radical 12. And we're going to make it 4 times 3. So we've got 3 root 3 minus radical 4 root 3. So we've got 3 root 3, right? We can take the square root of 4 out. And what does that become? 2. Now we see they are actually like terms. What does that equal? 1 root 3 or just root 3. Okay? So we always want to simplify it before we start trying to add or subtract them. Okay, so we want to simplify them first. Okay, let's do another one. Let's do 2 root 8 plus 3 root 27 minus 4 root 32. Okay, so at first glance, we don't see any like terms, right? So let's go ahead and simplify. So the 2 root 8, so we're going to rewrite the 8 as 4 times 2. 3 root 27, let's write the 27 as 9 times 3. And the 32, let's write that as 16 times 2. Okay. So I'm going to write this out so everybody follows what we've done here. 4 is 2 times 2, right? And then we've got 9, which is 3 times 3. And we've got 16, which is 4 times 4. Okay. So we take our pairs out. Good. They come out. These come out. And these come out. Okay. And that leaves us with 2 times 2. Everything that comes outside gets multiplied together. 3 times 3, root 3. 4 times 4, root 2.
Was this the curveball you're talking
This is the curveball. So we have 4 root 2 plus 9 root 3 minus 16 root 2. Can we combine any like terms?
Yes.
Sure can.
4 and 6.
Yeah, these are like terms right here.
Ms. Murray, you could have just skipped all of those 2 rows, 2 ones above the one you just did.
Yes, if you could go directly from here to here.
Okay.
Okay, so what's that leave me with? 9 root 3 minus 12 root 2. Now we're finished. So we simplify it first, and then we combine our like terms. Nico, you have a question? Okay. Okay. We simplify it first, and then we combine our like terms. Okay. Questions? Yes, I heard yes. What's your question? Okay. Okay. I have a worksheet for you. When you finish the worksheet, you're going to upload it to Google Classroom, and then we'll go over the worksheet together. Okay?
Sorry.
Yeah. Okay, so we already discussed the first one. If I have 2 of these root 6s and I give away 2 of the root 6s, I'm left with 0 of the root 6s. Right?
Let's go.
Okay, number 2. So they don't appear to be like terms, but I can simplify the 8. I can make that a 4 times 2. Right? And I know the square root of 2 is 2. Square root of 4 is 2. So now I have 2 times 2 root 2 plus 3 root 2. That gives me 4 root 2 plus 3 root 2, which equals 7 root 2. Ladies, please turn around. Thank you very much. Okay. Okay. Number 3. Ava, what did you do?
I had 5 negative root 54.
Good. And before I go any further with that, let me just answer a question or comment on something that I think someone asked. Can you have a negative square root? You can have a negative square root, but you can't take the square root of a negative. So you can't do this, but you can do this. Okay? Okay, so simplifying the square root of 54, what you do?
I got 3 and 2 to the square root of 6.
Okay, so we're gonna simplify this as 9 times 6, right? So I don't want to confuse everybody. I'm gonna do 9 times 6. And then 9, we're going to rewrite as 3 times 3, and then 3 times 2. Okay, so now we can take the 3's out. So we have negative root 6 minus 3, and then we'll multiply those back together. It's root 6. Everybody good with that? Okay, so Patrick, what's that give me?
That is going to get you -2.
No. Angel, what's that going to give me?
What did I just? Positive 2.
Cam?
-4 and then or 6.
Yes, negative 4 square root of 6. We're subtracting. I take 1 away, and then I take 3 away. Now I've taken 4 away. Okay. All right. Walker, how about number 4? What'd you do?
I do mine kind of a weird way, but I do 9 times 2 under the 18.
Okay.
And then turn the 9 into 3 times 3. And then I just bring down the rest. So I do 2 root 2, and then 2 times 3 root 2. And then I bring it down again, and I do 2 root 2 plus 6 root 2, and that's just 8.
Okay. So we factor the 18, so we're going to rewrite this as 2 times the square root of 3 times 3 times 2. Now we can take these 3's out. So now outside, we combine what's outside, and we're left with the 2 inside. So now we have 2 root 2 plus 6 root 2. Angel, what does that give me?
That would be
8 root 2. Yes, very good. Okay, 8 root 2. Questions? Okay. MJ, how about number 5?
I had put, well, I put 2 square root 6 in plus 6 times 4. Well, I didn't put the 2, like I put 6.4.
Okay, so you factored the 24, 6 times 4. Okay. Don't forget, we got to leave that 2 there, right? That doesn't disappear. That's still going to be outside.
Oh, well, and then I brought that out and then I put plus 4.
Good. Okay, so taking the square root of 4, that's 2. That comes outside. So now 2 times 2 is 4. Okay. Root 6. Perfect. Excellent. Okay. Any questions so far? Okay, Tristan. Saved a good one for you. Well, let's talk it through, right? So can we simplify the square root of 18? Yes. 9 and 2. Good. Okay. Now, we can't simplify the root 6 because 6 is just 3 times 2, and we can't do anything with that. So we're going to leave these alone. Okay, so how about this? What can I do with this 9 and 2? 3 times 3, okay. And then what? Okay, let's bring those 3's out. Right? So when I bring the 3's out, I have 6 outside and 2 inside. Okay, now let's look and see what we have. Okay, so where are my like terms? Yeah, these are like terms. The radical has to be the same. So if I have 6 of those root 2's and I'm adding 3 of the root 2's, how many root 2's do I have? 9 root 2's. This stays the same. I can't do anything with that. So that's our answer like that. Okay? Because there's no like terms for that. All right, everybody okay? All right. Angelo, how about number 7?
So you could just like keep it 2,
Okay,
and then I did 9 times 3,
good. I'm going to simplify that 27 is 9 times 3.
and then I did 6 times 4,
Okay,
and then I simplified to 3 times 3. Yeah, and then I brought the 3 outside, so it would be -6 square root of 3 for that.
okay. So these 3's come outside, so we get -6 square root of 3. Okay,
And I did 2 times 2.
good. So the 2's come out.
Yeah.
Now what?
And then you simplify, so it would be -8, 8, 3.
Excellent. So those are my like terms. Very good. Okay. Questions on that one? Okay. Rod, how about number 8?
You just combine your like terms.
Yeah, there's no simplifying to be done because 5 and 6 are not going to simplify out of the radical. So we're just going to combine those like terms. And what do we get?
Negative √5 minus √6.
There you go. Excellent. That was like so easy after the hard ones. You kind of feel like you're doing something wrong, right?
Yes.
Okay. All right, Timmy, number 9. Okay, so we'll change the 27 to a 9 times 3. Okay, let's keep going. Okay. Good. So then we have a 9 outside and a 3 inside. Okay. Okay, so we're combining these two. Is that what you said? Okay, the air conditioner came on. It was hard to hear. So we're left with 11 √3. There you go. Okay, very good. All right, last one. Now, the last one, okay, I could simplify it, but I don't have to. Okay, it's not wrong if I simplify, but it's going to be more work because as soon as I looked at this, I noticed I have 3 of these √27s and the opposite. So I take 3 away and I add 3. If I have the same that are opposites, what does that equal? 0. So those are going to completely drop out of the whole equation, leaving me with 3 √3. So we didn't have to simplify that one. Okay? Okay, listen. We're going to stop there if you can stay quiet for the remaining 15 minutes. Okay. If not, we'll do some more.